Oh, hello, testing. All right, microphone is working. All right, let's get started back on the stream and just going to be doing more Leetcode, sharing my entire screen. All right, sweet. Okay, doing meta tag questions. Let's see, which one do I like? Let's do this one. It's an easy. All right, kth missing positive number. We're given an array ARR of positive integers sorted in a strictly increasing order. Okay, so our array is sorted in a strictly increasing order, okay? And an integer k, all right? And we need to return the kth positive integer that is missing from this array. Okay, so here our array is this one, and k is 5, and we are returning 9. And then the explanation is the missing positive integers are 1, 5, 6, 8, 9, 10, 12, 13. Yeah, because we have 2, so 1 is missing. We have 3, 4, and then next one is 7, so 5, 6 are missing, and then 8, 9, 10 are missing between 7 and 11. So the fifth missing number is 1, 2, 3, 4, 5 is 9. Okay. Yeah. And then here, 1, 2, 3, 4, k is equals to 2. So we see that from 1 to 4, there's no missing number. So we just do a 4 plus 2, which is 6, is our second missing positive integer. Okay. And then could you solve this problem in less than O of n complexity? Let's see. So I guess this is like a range problem. So first we compare from 0. Like our range would be, let me just walk through this example. So to explain it better, oh, I forgot to start my timer, but I think I'm like 2 minutes into the interview. Yeah, almost 2 minutes. All right. I'm going to be walking through this example. So we are just comparing range to find missing number, kth missing number. Okay. So the first one we have from 0 to whatever the first element is. So 0, 2, and then we have 2 to 3, and then we have 3, the range to 4, and then we have 4 to 7, and then we have 7 to 11, and then we have 11 to, I guess maximum is just whatever k is, right? So as we go through these intervals, we can decrement whatever k is. And then once we have found our k, we just return it. So for example, k is 5 here. So here, initially k is equals to 5. And then we see that, I guess, if k is within this range, say this was 6, then 0 plus 5 would be our answer. However, this is 2 initially. So we see that there's only 1 missing here. So we have to decrement this to be k is equal to k minus whatever the n minus the start is minus 1. So 2 minus 0 is 2 minus 1. So k at the end is equal to 4 because we have found the first missing positive number, which is 1 here. So now, why does it do period like that? It's annoying. K equals to 4. And now 3 minus 2 minus 1 is 0. So k is still equals to 4. There's no missing number that is positive between 2 and 3. So now k is still equals to 4. Again, 3 and 4 is consecutive. There's no missing. So here, k initially also equals to 4. But now we have to update k. We know that 5 and 6 are missing. So 2 numbers. So 7 minus 4 is 3, minus 1 is 2. So now k by the end is set to be equals to 4 minus 2. So now it's 2. All right, 7 and 11, k is 2 initially. However, 11 minus 7 is 4. 4 minus 1 is 2. So we know that is within this range. So we just do a 7 plus 2, which is 9. So we just return 9 here. And that is basically the logic. We just get the intervals, and then we just check that the start interval plus the end. Um, I mean, the start interval plus the remaining k is less than is less than the end interval, then we just return that. Otherwise, when we exit out of this and k is still remaining, then we just do a whatever the n was plus k. So we can just begin our answer. Cancel my timer real quick. All right, begin our answer. So int start is equals to 0 initially. Int n is also equals to 0. Okay. And now we just do a for loop for int I equals to 0. I is less than array length I plus plus. So we need to update the end would be equals to array at index I. Okay. So now we just check if basically start plus k is less than end, then we can just return start plus k. So for example, in this example, when k is equals to 2 and the start is 7, 7 plus 2 is 9, so we just return 9. Else, this is when we move on to the next example. K is equal to be this formula here. So it would be k would be minus equal uh, n minus start minus 1. And then we need to update the new start to be end, and then we move on. If we go out of this for loop and we have never found our answer, then there should be some k remaining, right? Then we do a return, basically n plus k, just like that. This should work. I'm going to submit. Yeah, the time complexity for this solution is, let me just write it here, O of n, where n is number of elements in array. Because in the worst case scenario, we have to go through every element and just add k to the end. All right, space complexity is O of 1 because we're just creating two variables here. So nothing additional. Let's see for the follow-up. Can you solve this problem in less than O of n complexity? Okay. I guess I can do a binary search. Would that work? Because the input array is already sorted, but I'm not too confident how I would find k. Let's go to the editorial. Brute force O of n time. Yep. Binary search, of course. Let's try to solve it in log time using binary search, okay? So we need a way to check on how many positive integers are missing before the given array element to use binary search. Let's compare the input array with an array with no missing integers, okay? Two minus one. Before 3, there's 3 minus 2. 4, there's 4 minus 3 missing integers. Before 7, there are 7 minus 4, which is 3 missing integers. Before 11, there's 11 minus 5, 6 missing, okay? So the number of positive integers which are missing before the array at the current index is equal to array at the current index minus the index minus 1. Okay, so let's see if that's true. So this is index what? 4, 0, 1, 2, 3, 4. Okay. So it's equal to 11 minus 4 minus 1. So 11 minus 5, which is 6. So that's the pattern. Okay. So now we have to proceed with a classical binary search algorithm. Choose the pivot in the middle. Okay. And then if the number of positive integers which are missing before array pivot is less than k minus is less than k, then we continue to search on the right side, okay? And otherwise, we continue to search on the left side, okay? Pivot plus 1, pivot minus 1. At the end of the loop, I'm gonna try and implement this myself after understanding. So I'm not gonna look at the solution. So at the end of the loop, left equals right plus 1, and return the kth missing number is in between array right and array left. Array right plus k minus array right minus 1. What are you returning? So we don't check for equality at all. Interesting. Left is equals to right plus 1. And the kth missing number is in between right and left. The number of integers missing before right is... Oh, so we're eliminating that. Okay. And then just adding it to the k. Left has to be greater than 1. Okay. So whatever is to the right. Array right minus 1. Okay. This is a weird implementation. I'm trying to understand. So at the end of the loop, then, for this condition to break, left has to be to the right side. Okay. And the kth missing is in between array right and array left. Let's see. I don't understand this. Yeah, I'm trying to understand this one. Yep, number of missing elements before the right index. Missing elements to be found. As we might have already encountered missing elements to the left index, we subtract from k. Yeah, that's what we're doing. Minus right minus 1. Yeah, so the formula is the number of missing elements from an index is whatever the value at that index is minus the actual index minus 1, right? That's the formula. Who is discording me? Current missing. Okay. So we're just doing binary search. If k is less than... Well, that's not binary search, is it? That's brute force. All right, I'm going to try and attempt the binary search problem to see if I understand it. I'm going to delete this. Well, first I need to check is if k is in between 0 and the first element. So if k is less than array index 0, and return basically k. Otherwise, what is k? K would need to be subtracted by whatever is at index 0, right? Why are we subtracting it? Because we have eliminated, say our example here, right? 0, the first element array 0 is equals to 3, and k is equal to 4, then we need to do a 4 minus 2 because we know that 1 and 2 are missing, so minus 1. Okay, so now we do our binary search. So int left equals to 0, int right is equal to basically array length minus 1. Okay, so while left is less than or equals to right, basically we get mid is equals to left plus right divided by 2. Okay, then we check